Lesson 4.3. Warm-up problem. Let's see how we did. Okay. Probably the two easiest to find, or ones you'd like have to, would be 2 or 3. So I found 2 first by just taking 90 minus 53. I see that right angle symbolized for me, so I know I have to total 90. I got 37. And then sometimes too, it's helpful to like write in the triangles as you go. That's 37 degrees. So then we can find angle 1. Because obviously this little triangle in here, those angle measures have to total 180. So for angle 1, I did 180 minus 74 minus 37. 69 degrees for angle 1. Angle 3 is a linear pair, or you could say like supplementary, with angle 74 degrees. So those have to add up to 180. So I did 180 minus 74. It's 106, right? 106 would be angle 3. And then lastly, angle 4 in this triangle. Now that we know angle 3, those have to add up to 180. So I did 180 minus 53 minus 106 to get 21. How do you do?
I'm on my
Tyler, what did you do wrong? 4 for 4? Nice. Okay, next one. Somebody give me the equation they set up in letter A to solve for x. Gwen?
9x plus 2x plus 5 plus 6 minus 2 equals 100.
Perfect. This is one of like the theorems we talked about in lesson 4.2 that all the angle measures have to total 180. Okay, if you added up all the like terms, you should have gotten 6x minus 12 plus 12 equals 180. And then when you solve for x, subtract the 12 over 168, divide by 6. I got x to be 28 for that one. Ooh. Okay, that was one theorem. We talked about the other theorem is that exterior angle theorem, where if you have an exterior angle to the triangle, because it's supplementary with this angle, meaning those two have to total 180, and this angle and the other two angles also total 180, we could say that this exterior angle is the same as those two added together, because with that third angle, they both have to total 180. So that should have been the equation you set up for this one. I think it's just called exterior angle theorem. I can't quite remember off the top of my head. And then when you solve this one for x, 47. I move the x's over to this side. And then got x to be 23. Don't worry, you'll get more practice on your book assignment tonight of problems like this if you struggle. So these are like the problems, the types of problems you'll have some of like these on your quiz tomorrow because your quiz is over 4.1 and 4.2. And then 4.1 was like classifying triangles by its side and by its angle. So like equilateral, scalene, isosceles, you have to know all those vocab. Classifying by its angle, right triangle, obtuse, acute, equiangular, that good stuff. So today in 4.3, and then we'll finish these notes today, they're kind of short again, we're talking about congruent triangles and how we can decide and prove that two triangles are congruent to each other. Okay, so we have our first definition of congruent polygons, and this works for more than just triangles, but we're mostly going to do triangles in this section. We can say that two polygons are congruent if and only if their corresponding parts are congruent. Corresponding parts mean angles and sides. So it's not enough to just decide if they have like the same angles. We can't decide for sure if the two triangles are congruent. You have to show that all of the corresponding sides and angles are congruent. All right, now corresponding. That means if you're looking at this example, and we can see all these congruency marks. I'm going to start with angle B here because it has one arc length. They're showing me with that one arc length in triangle ABC that angle B is congruent to which angle of this triangle? J, right? Okay, so we call those like corresponding angles. And as long as all the corresponding angles and corresponding sides are congruent, then we can say the triangles are congruent. All right, so let's list out all the corresponding sides. We have angle B is congruent to angle J. All right, I'm going to go next to the one with the two arcs. So angle A is congruent to which angle of the other triangle? H. Those are corresponding congruent angles. And then lastly, we have C and K. And be as precise as you can. So notice how like I always listed first the angles in like that triangle ABC and which ones they're congruent to in triangle HJK. Keep it consistent. You want to correspond as much as you can. So we notate angles are congruent with like the arcs. Sometimes if you run out of arcs, you might see like this notation where you have like an arc with a line through it. Okay, so like those two would be congruent. How we notate congruent sides are those dash marks. So right here I have one dash mark, and I'm going to call that, let's say I call it AB, side AB. Side AB. And notice how I started with angle A, or I should say like the vertex A of that triangle. If I want to say which side it's corresponding to, I went from the double angle to the single angle, so I'm going to have to keep it in that corresponding order. I'm going to have to call this side length that it's congruent to its corresponding one HJ. So you could have flip-flopped. You could have called it BA, but then you'd have to do it in the corresponding order JH. All right, so, keep these consistent. Those correspond to each other. Okay, so then I could say BC. That one has a double, the double dash. BC, side length BC, and I started with the single angle, so I would say that's congruent to JK. So I went from single to triple. All right, now the last one, let's go AC. Again, that order doesn't really matter, but you just have to keep it consistent. So I'd have to say HK would be its corresponding side length. Okay, does that make sense? You got to keep it in order, and I will be picking. I will take out points if you don't do it in the right order. Just one. So if this is true, if all the corresponding angles and all the corresponding sides are congruent, that means the two polygons are congruent. So in this case, we could say triangle. All right, let's just go in alphabetical order, ABC. So if I decide to do alphabetical order here, starting with the double angle ABC, I have to go in this order, JHK. No, that's not right. HJK. Sorry, I start with the double angle. HJK. Yeah, that's right. Triangle HJK. Maybe I said that. I can't remember. I guess I could watch the recording. So just make the note that these have to be in like corresponding order. This we call the congruent statement. It would not be okay to call that triangle like JHK or something. Because this, even if you just have the congruent statement and like no picture, then you know like, oh, angle H is congruent to angle A. Side length BC is congruent to side length JK because they're in that corresponding order. So we have this theorem that we're going to use in a couple proofs. So here's what I want you to just jot down. Just put a theorem we use in proofs. I'll explain what it is. It's pretty self-explanatory by its title, and its title is not short by any means. Corresponding parts of congruent triangles are congruent. Okay. So if we knew this congruency statement, if we knew triangle ABC is congruent to HJK, then we know all their corresponding parts, whether that's angles or sides, are congruent. Okay, so if we know these two are congruent, you could pick out any angle or any side, and the corresponding ones, those will also be congruent. If triangle, I'm just going to use the example that we used above, ABC is congruent to HJK, that's what this theorem is, we can find all congruent parts by this theorem. All right, now I often just abbreviate as CPCTC. I wrote that right here. Corresponding parts of congruent triangles are congruent. We also use this like in the converse, like if we could show all the angles and sides, all the corresponding parts are congruent, then we could conclude the triangles are congruent. You could technically use this theorem, I'm okay with using that, or you could just say like definition of congruent polygons, because this works for all polygons. That if all the corresponding angles and sides are congruent, so are the polygons. Okay, sorry, questions? I'll let you write that down now. We'll try some examples. Of course, it's fun. Some algebra too. All right. Show that the polygons are congruent by identifying all of the congruent corresponding parts. That means angles and sides. Then write a congruence statement. All right. I usually start with angles. I don't know why. I just do. All right, I'm going to call on random people. Look at all the markings there. How many total angles do we have in this polygon? 5. So lots of corresponding angles here. Malin, give me one pair of corresponding congruent angles. Look at the markings.
B and C.
This one has 2, this one has 3. Oh. And I'm talking about 2 separate. So we'll start with angle A. See how it has 1 marking?
Yeah.
All right, and the other polygon, which one only has 1 marking? P. So you could say angle A is congruent to angle P. That's one pair of corresponding congruent angles. So another thing with this, guys, obviously like the orientation doesn't have to be the same. Orientation meaning like which way it's kind of like facing. So this one, if you look, you would kind of like call this your base. This one looks like it got like kind of like flipped upside down, but this corner is over here, so it got like turned a little bit. This one, if this angle A is corresponding to angle P, like I can almost just like take this one and like set it up, and then they'd be like the exact same like orientation. So keep in mind like this obviously still holds true even if their orientations are different, if they're like flipped upside down or rotated, all that good stuff. All right, Matthew, could you please give me another pair of corresponding angles?
Angle B and angle Q.
Oh, I like how you went in order. B and Q. Good. Ben. Another one.
Angle C and angle C and angle R.
Good. Angle C and angle R. Those ones have the triple markings. And usually after that, folks, they start going to the slash with the line through because it's kind of hard to draw like 4 or 5 arcs after that. It gets a little congested. Tyson, can you give me another pair of congruent? Good. Angle D is congruent to angle S. They marked that for me. Last one, Trinity.
Angle E is congruent to angle T.
Perfect. Angle E is congruent to angle T. Okay, so we've shown that all angles are congruent, but that's not enough in order to say that these polygons are congruent. We have to show that all their sides are congruent. That's also marked for me with these dashes. Let's list out all the corresponding sides now. Now, the order matters. So if I look at this like first side of each of these polygons that has the 1 dash mark, if I'm going to go from, let's say, like this single marked angle A, I'm going to call that AB, side AB. I went from the single angle to the double angle, and I'm just talking about the marking, so I would have to call it PQ. Okay, those sides are corresponding congruent sides. Walker, can you give me another one? Another side?
B, C, and QR.
Good. Said that in perfect order. He said BC and QR. Love it. Jessa, can you give me the next one?
C, A, and RS.
Good. CD and RS. Tech.
D, E, and S, T.
DE, perfect. And ST. Goes into tab 4. Kaylee, last one.
E, A, and TP.
Good. EA and TP. Okay, so there's the first part. Show that the polygons are congruent by identifying all the congruent corresponding parts. So all the angles on the sides. Then to write the congruent statement. Oh my gosh. Do you guys see this marker? It's just the most annoying thing. All right. Now the congruent statement is polygon let's just start with the first arced angle. So we'll go clockwise. A, B, C, D, E is congruent. So if I started with angle A, I got to start with angle P when I'm naming that polygon and go in the same order: P, Q, R, S, T. They're not always going to be in alphabetical order either. They usually are, but just be careful with that. Because it's not 100% of the time always in alphabetical order. Okay, I don't think we need to practice another one of those. That was a lot. Obviously a little bit more challenging than triangles, because triangles you would only have to do 3 angles and 3 sides. This for me to do 5 sides and 5 angles. Do you guys remember the shapes that have 5 sides? What they're called? Pentagons. Nice. You could have called it pentagon if you wanted to. All right, let's do some algebra ones. In this diagram, they're giving me the congruent statement, or they're telling me that triangle ITP is congruent to triangle NGO. So you can see here's one where they're not like in alphabetical order, right? So if angle I, or I guess the vertex I is listed first, they're telling me that I is congruent to N, and then T's next. T is congruent to G. P is congruent to O. That's what that congruent statement shows us. Those are like the corresponding congruent angles. So I have to find x and y, or I have to algebraically solve for x and y. But right away I know that angle O and angle P are corresponding. And I know they're congruent because the triangles are congruent. So we could set up that 6y minus 14 has to be 40 degrees. Okay, we have to do this step first because if you look at the other side, it involves y. So I have to solve for y first. So add 14 divided by 6, we get y is 9. Okay, now let me ask you guys this question. This side, NG, that I want to find next, the one that has the x in it, what side does it correspond to in that other triangle? Gwen? IT, yep, 7.5, right? It goes from that single angle to the double angle. Or you could say that it's like across from the angle we just found. Across from like the smallest angle. If you were to like tip this triangle up, like that would be kind of like your base. You're gonna look at that. So we know that x minus 2y, if these are corresponding side lengths, they have to be congruent. So it has to be 7.5. And now I know y is 9. So I'm going to need to use that. So x ends up being 25.5. Okay, that's kind of fun. All right, you guys try this one quick. This time we have triangle FHJ is congruent to triangle HFG, and they share a side. Ooh, tricky. See if you can figure out x and y. Look at the congruent statements. Make some markings. You need to. Get some decimals, that's okay. You got 1 minute. All right, FHJ, I'm going to trace that triangle. And then they say is congruent to triangle HFG. So if they're listing angle F first in the blue triangle, it's congruent to angle H. Let me use my colors here. I'm trying to think of the best way to do this. Angle F in the green triangle we know is congruent to angle H in the blue triangle. So we know this one is congruent to this one. You could also kind of go through and identify like the congruent sides, like, let's see here, H, J. Oh, that's not what I want to do. What about JF? JF, like the last one here, is congruent to GH. Like those are kind of my bases, and you can kind of picture like these are the tips of my triangle. So those are the corresponding angles. How we need to kind of identify it. So to set up your equation to find x, you should have set it equal to 35. And you're like, yeah, I kind of guessed that because that was the only measure they gave me, but connect it back to the congruent triangle piece. So I got x to be 4.5. 4.5 is fine. And then for y, I kind of marked those corresponding sides. So that 2y minus 3 is the same as 2.5 of the green triangle. So for that one, I got y to be 2.75. Kind of, I don't love that example because those are like the only numbers they gave you. So even if you didn't really know what to do, you can probably guess what to do. But look at the congruent statement if you're confused. And that one they shared a side, so it was a little maybe tricky that way, I guess. But all right, you want to those to practice in your homework. We only need to talk about one theorem, and then we're going to do a little 2-column proof, like the good old algebraic proof days. It's not too bad, though. It's only a 4-stepper. Okay, here's our last theorem of this lesson, and it seems pretty obvious, or like common sense, I guess. If we know 2 angles in one triangle are congruent to 2 angles of a second triangle, then this third angles theorem allows us to conclude the third angles are also going to be congruent. Okay, why does this make sense? Well, obviously, if these 2 angles have the same measure as these 2, what do these 3 have to add up to? And what do these 3 have to add up to? So when it makes sense that these would also have to be the same because these are going to sum the same and they are the same. Okay, yep. So in this example, if we knew, here's the hypothesis of this theorem, if we knew 2 of the angles are congruent, like angle C is congruent to angle K, and angle B is congruent to angle J, then you can conclude the third angle is also going to be congruent. So in this case, angle A would be congruent to angle L. Okay. So I'm going to do a little proof. Quick, and then we'll call it a day. You have this diagram, and here's what's given to me. Angle L is congruent to angle P. Side LM is congruent to PO. Side LN is congruent to PN. Okay, here's where I think there's a typo in your notes. Side MN, I think it doesn't say ON, does it?
No, it says OP.
Yeah, you gotta change that to ON. Because OP is PO and that one's elsewhere. So MN is ON. ON. Okay, that's the information that's given to us. They want us to show that these 2 triangles are congruent. Now, in order to do that, you have to show that all sides and all angles are congruent. What's already done for us? The sides, right? So we just got to finish up with the angles. Now, remember in the 2-column proofs, anything that's given to you, you have to state. So my very first step in this proof would be to state all that stuff that's given to me. So you're just going to recopy all this. Angle L, I'll just do it in the same order as them so you don't get confused, is congruent to angle P. Side length LM is congruent to side length PO. LN, side length is congruent to a PN. And side length MN is congruent to ON. So when they say 2-column proof, guys, Remember when he did these, and then over here in the second column, you have to give your reason, and this is just given. All right, so Matthew said all the sides are shown that they're congruent. So we don't have to do anything with those. So I'm kind of looking at the angles, and I need to show that all the other angles in this triangle are congruent before I can jump to what I'm trying to prove. And this gives you like a little roadmap. Like this is telling you like where your destination is. We're trying to prove that the triangles are congruent. So that gives you a little bit of idea too of what steps you need or where we're trying to go, I guess. It's like a puzzle. All right. Any ideas of other angles that we know could possibly be congruent on those two triangles? Alejandro, what do you think?
Angle M and angle O.
Okay, why?
Because they're connected to side LM is congruent to side PO, and so is side MN and side ON.
Okay, I like your thinking here. Let me show you this example. Let's say these are the same length, and so are these. Is that enough information to say that these two angles are the same?
No.
No. We will have to show that eventually. We can't jump there yet. Like you're thinking of. Other ideas. Good idea. Libby?
The two angles by N are vertical angles.
Ooh. Do we agree you have some vertical angles here? Okay, so we're going to call those, let's be specific. Let's call it angle, if I'm going to start at the single angle mark, angle L, and then go to the vertical one. NM is congruent, so I'd have to call that angle P, starting at the single angle, PNO. Well, you said this perfectly, vertical angle theorem. Okay, now Alejandro was right. These two angles are congruent, but the justification was not quite correct yet. So now we can just call this angle M is congruent to angle O. Other ideas of how we could say that those are congruent. Dakota? Third angle theorem. If we know two other angles are congruent, the third angle also has to be congruent. And now that we have proved every single angle, here's my three angles, here's my three sides. Now we can determine or conclude and state that those triangles are congruent, L, M, N. Notice how they kept it in that congruent order. Triangle P, O, N. You could put two things here that I'd accept. You could say definition of congruent polygons, or you can use that congruent parts, corresponding parts that are congruent. The triangles are also congruent. The CPCTC, this one, I'll go back to it. I'll come back. This one. Corresponding parts of congruent triangles are congruent. It's kind of like the converse, but I'm okay with you using that reasoning as well. Or you could just say definition of congruent polygons. That was fun. There's only one like that on the worksheet. Okay, that's a wrap on 4.3. I'm going to stop the recording.